Again, welcome everybody. So my second 2.5 session, or 2.5 session of the day. Azure Active Directory pass-through authentication and single sign-on authentication, or seamless sign-on as we called it. That's me again. So as I might have iterated a few times, I have my own blog. It used to be studiographic.nl, and then I thought let's go international, so it became azureinfra.com. So take a look at it. It has most of the stuff that I'm actually presenting. It's on there, but it's also Azure Stack, it's VPN, it's networking, it's identity, and everything else that I like that only has to do with technology. So the agenda for today is just briefly going to go over the authentication options and what the differences of those are. Don't worry, I won't go into what everybody else has already said. And then which one of those you would actually choose for which particular scenario, right? What are the pros and cons of each scenario? Then I'll go into pass-through authentication. I'll actually go into pass-through authentication, what actually happens with the credential verification. And it goes up to the level that you can actually go to your security guys or security team and actually explain to them that this is a safe option. And then we'll go into seamless sign-on, see how that actually works. And as I said, it's the same. I'll go as deep as you need to, as I need to go to, for you guys to convince the security guys that it's actually a safe option. And then lastly, if we still have time for it, some protection for account lookouts. So to start off, there are two types of domains that you can have within Azure Active Directory, right? The type of UPN that you specify. You can have managed, and managed basically means you provide your username and password into the window of Azure Active Directory. And it either gets validated by Azure Active Directory or it gets sent over a link to your on-premises Active Directory. But your user provides their username and password into Active Directory, Azure Active Directory. Or you do federated, and that's where we basically trust your endpoint. And that can be Okta, it can be ADFS, it can be Ping, it can be anything others. You do your authentication over there, you come back with us with a token, we trust that token, and therefore you get a token from us. So I said, so the federated domain, you provide your username and password always to your local service, and then you provide that ticket to Azure Active Directory. And there's only a trust between ADFS and Azure Active Directory, and there's no data flowing over that trust itself. So it's not an active link, it's just a trust link. When you do managed domain, you can have your users sending your username and password directly to Azure Active Directory. And this example is where you have a cloud-only account, as I call it. So the password of the user is in Azure Active Directory. With pass-through authentication, what we do is you still provide your username and password into Azure Active Directory, but your password is not stored in Azure Active Directory. It actually goes down over a connector, and the connector validates the password on behalf of you. Right? And last, we have the seamless sign-on. I thought initially it was for pass-through authentication domains only, but apparently it works for all of the domains, including federated. Right? So what happens here is you provide your username and password to the Active Directory. You basically get a token from the Active Directory. You provide that token to Azure Active Directory, and Azure Active Directory says, yes, you validated, you're logged in. Pretty simple.
Through the connector, right? Or how does it
No.
validate?
So we'll go into the details later on.
Thanks.
So there is an AD connector, but the AD connector is only for the setup, and afterwards it doesn't do anything anymore. You can basically shut down the machine and you don't need it anymore. So which one to choose? So the federated authentication was the first authentication model where we said if you needed to do a single sign-on, or if you brought your own MFA provider. Right? If you have SafeNet, for example, RSA is currently sort of built in, but it wasn't the case in the past. Or if you use Symantec VIP, as one of the other speakers told us. You would also use federated authentication in most of the times if you already had an ADFS or a federation farm for all your other applications as well. Because it made it a lot easier and it made it a lot simpler for users because it would be the same UI that people would provide their username and password, right? A managed domain, and you can actually have a managed domain in password sync as well as in pass-through authentication. A managed domain in password sync is the easiest one you can have because you're just synchronizing usernames and passwords, but you don't have single sign-on. So if you have a corporate account, and I'm taking into account you don't do workplace join, but if you have a corporate account and your machine is joined to the Active Directory, you don't get single sign-on to your cloud services, which isn't really friendly. You can have MFA, but the MFA is only Azure Active Directory MFA, or since Ignite, one of the supported cloud MFAs that integrate with Azure MFA in Active Directory. Right? And you have to convince your security department to actually send your passwords over, or password hashes of the hash, to Azure Active Directory. The managed domain pass-through authentication, and that's actually where you still get the benefit of additional protection against brute force attacks. Because the downside of ADFS was you had to bring your own farm, your own proxy services, your own high availability, load balancers, and the whole shebang. With pass-through authentication, you don't have to do all of that. And I'll explain later on why. There's no additional infrastructure required because it only requires like 2 or 3 agents to be fully highly available and to be able to cope with the load of, I think we're like 100,000 users or something. So it's a very lightweight client. 2 or 3 of them is usually enough for a big enterprise. You can install them on any Windows machine as long as it's 2012 R2 or upwards. And the Azure AD Connect is always the first one. It's very user-friendly because you don't have to type your username and password in like different windows. The problem I have with federated authentication is that a user goes to My Apps, for example, he types his username, and then he gets redirected to ADFS. If you're lucky, your username will be copy and pasted. But if you're on a mobile phone, take for example the Yammer app, you type your username, you type your password, you click login. That's when the ADFS redirect actually happens. You have to retype your password, click login again, and then you're logged into your mobile app if you don't do MFA. Right? So it's really annoying for the users. The advantage of pass-through authentication is you just provide your username and password, you click login, everything happens in the background, and you're logged in. Right? I think that's a pretty big bonus. So as I said, so what's pass-through authentication? You basically have an agent on premises that talks to your domain controller, and your user provides its username and password to Azure Active Directory. So let's dive in what actually happens. So the components themselves that are involved with this is on the Azure Active Directory side. You have the STS, that's the page that you see where you put your username and password. You have a hybrid identity service, and that's the service that keeps your domain. If the type is managed or federated or pass-through authentication or seamless sign-on. There's an SQL database, there's a service bus, and there's actually a PKI infrastructure in there as well. So let's see what happens when we enable pass-through authentication and we enroll the first agent. So when you install PTA agent on the Azure AD Connect, it actually runs as a network service. So it doesn't have any special privileges on the computer account itself. But there is a second service as well. I didn't put it in here. There's a second service as well, which is the local system service. And that one is only for updating the agent. And it needs to have local system because it needs to be able to deinstall the old version and install a new version. But the runtime for regular users is under a network service. So when you install it, it's going to ask you for your Azure AD Global Admin because it needs to create a credential package. So what it does is you provide your credentials, the credentials go to the STS, and you get a token back. Next, what it does is the PTA agent itself, it has the token that we just got, and it's going to do a private-public key pair generation, so it's going to generate a self-signed certificate. Well, it's going to not self-signed, it's going to generate a certificate request, right? So what it does with the certificate request is it sends that to the hybrid identity service, it uses a token to authenticate, it sends the public key as part of the CSR, right? So the private key stays with the agent. And then what the hybrid identity service does is the PKI infrastructure in Azure Active Directory signs that, so now it becomes a signed certificate. And what it does is it puts the public key into an SQL database. together with the agent name, location, and some other information as well. There you go. Once it does that, it sends back the signature to the PTA agent, so the actual valid certificate, and the private key of this server stays actually on this server. So once now we have that, so we have a full certificate now, right? So what we can then do is the agent can take that certificate and connect it to the hybrid identity service as the agent itself. So we don't need to have an AAD global admin account anymore. The agent is capable of authenticating itself directly to the hybrid identity service. So if you restart your server, as soon as it boots up, it does mutual authentication. And actually what the hybrid identity service will respond with is, if you're logged in, it will give you a URL and an access key for the service bus that you see over here. Right? So as soon as it's done that, the agent will create an outbound connection over 443 to the service bus. And that connection is kept alive. And this is the bootstrapping. So the agent is now ready to listen and accept connection. Right? So the first one, this one is obviously terminated afterwards. But this tunnel remains for as long as the agent is up and running.
Where does that UDCS come from?
So this is actually the, so it's Azure private PKI infrastructure. So the certificates get signed. The root for this certificate service is actually inside the agent as well. So it's a fully trusted certificate, but the certificate is only trusted by this agent and of course the infrastructure components that you have over here. But it's not a public certificate. So how does the login work? So the agent still has that connection open, and I have a user, and the user goes into My Apps or Office 365 or wherever, and he sees the username and password page. So he puts in the username and password, and what the STS does is it forwards the username and password to the hybrid identity service. And this is actually where it happens. You're either redirected immediately, but in this case it just asks you for the password as well. Sorry. So the hybrid identity service finds out that your account actually has pass-through authentication and that you're a synchronized account, and that's very important later on. It goes into the SQL database and it picks up the tenant ID, the agent public key that we have in there, and then what it does is encrypts the username and password with that public key that comes from the SQL database. It all places this package on the service bus itself. Right? So now we have an encrypted username and password on the service bus where the agent was already listening to. So the agent says, I found a new package. I'm going to download the package. And of course, the username and password is encrypted. The only guy that can decrypt this particular package is this particular agent using his private key. So after we decrypt the username and password, we can actually perform a net logon to a domain controller. And the domain controller will respond with accepted, need to change password, out of office hours or whatever it's called, or access is denied. The agent then creates a connection into the hybrid identity service with that particular response. And that's what the user sees. So the hybrid identity service takes that response and sends it back to the STS.
Question, on the piece about logging onto the domain controller, do you know what the logon type for that is?
I need to check because we'll see it in a minute, but I think it's logon type number 3. Right. It's a standard net logon.
What are the scenarios around an agent machine failing and having to generate a new certificate and having credential validation requests in flight that have already been encrypted?
So for the credential in flight, we have another, that's actually the next slide, because you can have multiple agents listening at the same time. Okay. So the service bus stays there. So the package is not removed from the service bus unless there's a response coming back. Right? It's just being reserved by the fastest agent. And as soon as that agent doesn't respond within a particular time frame, package is released and another agent can pick it up. For the certificate, you can actually do certificate rollover. So you can re-authenticate, basically use the global admin, and request a new certificate. Sorry. So who sees a problem if we are going to install agent number 2?
It's supposed to use the same encryption kit, right?
It's supposed to, but it actually doesn't. So each agent has its own unique key. That's like most important. So what actually happens is if I create a agent number 2, when the hybrid identity service looks up and says, I need to encrypt this package, it will see that tenant ID basically has 2 agents or 3 agents or 4 agents. It will encrypt the package 2, 3, or 4 times and place that package on the same service bus. Right? So that's why you don't install 1,000 agents, because it's going to increase the logon times. And that's why you only need 3 or 4 of them.
Or you could, the easier way would be just to encrypt the key, to generate the, to have the same key for all the agents that is being encrypted using different per agent keys. And then only the payload is encrypted once. But whatever.
Yeah. So they chose the method like this because you can basically discard an agent, disable it, without affecting any of the other agents. So if one of my servers gets compromised, I can delete the agent from my portal, and all the other agents would continue to work, and you know that they're unique. So I don't have to roll over any keys for those. Right? That's it. So I have a small demo. But the advantage of this one is, remember when I said that the hybrid identity service can take a look if your account is synchronized or local? Because this one has one very, very big advantage, which I will show you in the demo itself. So I basically have a client, which is my Windows Server 2016. And I'm logged on as a local admin, not as a domain admin or anything else. And I'm actually logged on to the portal as well. So if I now look in my portal, and remember this tenant actually has 3 domains into it: federated domains and managed domains. So the forestroot.net, for example, is a federated domain. So I cannot create any users in my Azure Active Directory as a cloud-only users because it's a federated domain. It doesn't allow me to do that. But my, where is it? Root domain is a managed domain. And this particular managed user, the source of it is Windows Server Active Directory. So it comes from on-premises. But I can also create a cloud-only user using the same domain name, rootdomain.eu, as an Azure Active Directory user. Right? So for this user, the password is on Azure Active Directory. For the other users, the password goes through pass-through authentication. And that brings up a lot of scenarios that you can now use. Because if I have a vendor, and I don't want to use B2B, but if I have a vendor and I need to give him an account just for my Azure Active Directory, I can create an account for him just on cloud. I don't have to give him an account in my Active Directory that's then synchronized. All right? So let's take a look at pass-through authentication itself. So the way that it works, usually people would go to myapps.microsoft.com. And I said the root domain one is the only one that has pass-through authentication enabled. I click this one, and it's going to ask me for my username and password. Note that on the top left, it's still login.microsoft.com. So I'm typing my password into Azure Active Directory. I try to log in. So what's happening now in the background, if I click sign in, it says it's working, and I'm signed in. So how do I know that this one was actually a pass-through authentication? Well, we can take a look at the security log. And I'll refresh it just so you think I don't cheat. There you go. So there are 3 logons, always for one login. So here it says an account has successfully logged on. The security ID that was executing this was the network service on this particular computer, because this computer apparently runs my, my agent, does a logon type number 3, and it's an impersonation for the managed account. That's the account I actually logged in with. Right? So if you use pass-through authentication, you can actually use like a monitor into your audit log to see who logged in when, from where, etc., etc. You can actually link them with the audit logs from Azure Active Directory, so that you see which application, where from, which IP address, etc., etc. But of course, it's really nice that you have pass-through authentication like this. But I wanted to show you the other one as well. So I have this one, and I had the cloud user, cloud only user. So I say here I'm logging in with my cloud only account. Again, it goes to log into Microsoft Online because it's just going to ask me for my local password. I type my password, and I'm logged in. This is an account that doesn't exist in my Active Directory. It only exists in Azure Active Directory. See if I missed anything from the demo, but I don't think so.
So how does that get resolved when you authenticate? Does the hybrid identity provider basically look in the local store and
Yeah,
then pass it?
it looks at the source of the account. If the source of the account is Windows Azure Active Directory, it can authenticate it locally. That's it. So pass-through authentication looks like the magic bullet, but there's some stuff that doesn't work or is not officially supported. So supported is user sign-in on all the web browsers and most of the mobile applications as well, as long as they use modern auth. User sign-in from all Office 365 that support modern authentication. So that means anything Office 2013 or earlier cannot use this. It just won't work. If you want to use Azure AD join to make sure that you have single sign-on based on your machine, that works as well. And since they released it, just a week before they released it, Exchange Active Sync support is there as well. Right? So that's pretty cool. What doesn't work? So officially anything Office 2013 or earlier, and officially what doesn't work is Skype for Business, including 2016.
It's a feature.
It's a feature, yeah. Like everybody goes over to Teams anyway, so who cares, right? So I actually tried it out in my tenant environment, and for me, Skype for Business works. But apparently they didn't test it enough yet, so that's why maybe they said it's not officially supported. Anything with PowerShell 1.0 for logins doesn't work either. And if you have Office 365 Pro Plus activation, with ADFS there was a trick to make it auto-activate. So as soon as your user logged in and opened Word, in the backend it would get an authentication token from ADFS because of NTLM or Kerberos, and then activate automatically. They officially did not release it yet, but I blogged about it, how you can actually make it work as well with password authentication. So when you, if you're thinking, yes, this is what I want to do and this is what I want to implement, then for the implementation itself, currently if you say in Azure Active Directory Connect, yes, I want to use pass-through authentication, it switches all your domains, including federated ones. So everything goes to managed pass-through authentication. You can switch back to federated on individual domains if you want to, but it's a manual task that you have to do outside of Azure AD Connect. Right, so that's pretty important. As said, the system knows to separate passwords created in tenant and replicated users. It requires only 2 or 3 agents. The agents do high availability, they don't do load balancing. First come, first serve. So you can have one agent taking 90% of the requests and the other two 5 and 5%. There's no saying in whoever does what, right? The first agent is always the Azure AD connector. I already said that. And it works with network logon. So that means that if you have a trust or a forest trust or a Kerberos 5 trust, that works as well. So you can actually authenticate users in a different trust, in a different forest, if you're on your local domain, as long as there's a Kerberos trust in between. The agents update themselves in terms of software. And they also do an automated certificate rollover, I think every 30 days. But if you are very suspicious, you can actually do it manually as well with the PowerShell. Right? And then it refreshes its private key on the local machine, refreshes the certificates, done.
I want to comment on the implementation, and I've drawn a blank on the PM's name, the PM's name, but one of the things that I'm concerned about, and I have not had to do this, is that if you want to switch your federated domain to manage to install PTA, you don't know how long it'll take.
Correct.
So if you have an implementation window of 2 hours or 4 hours or something like that, basically you put the thing, and if you've got 10,000 users in here, you just got to let it run. There's no way to know, and there's no way to test it. I mean, you could create a test tenant and populate it with 10,000 and hope, because he couldn't even pin it down to that. He said, yeah, well, maybe this time it'll take, but if there's a load on the system that's doing it and it's a Sunday and other people are doing it, maybe it'll take longer.
Yeah, so they're working, the last information I got was that they're working on making it available so that you can switch per domain name. So that eases it off a little bit, but still it's the same problem. Yep.
So, with the cloud-only user, is there any artifacts that get pushed back down to the Active Directory?
No.
Because an identity is more than just logon. You may need a communications contact object or to populate for Exchange.
Yeah.
or
So
you're gonna
currently
rely
it
on-
doesn't replicate anything back. A cloud-only user is ignored by the import.
Okay, so if you need to communicate with them, it's like,
Yep.
Is there any way to do it without Azure AD Connect? Or is that a prerequisite?
So the first agent is always installed by Azure AD Connect, and then the second consecutive agents, it's basically an install that you define. So that would work if you just put it on Azure AD Connect and then configure the second or third agent manually and then shut down the AD Connect. But the configuration of Azure AD Connect is as soon as you move into PTA, it automatically installs the agent for you and configures it and sets everything ready.
I was asking because we're using a different tool than Azure AD Connect, so
No,
then, okay.
no. So then we go to the second one, because ultimately password authentication is nice, but password authentication still asks me for my password, which ultimately what we don't want, and that's why most of the companies actually took ADFS. So ADFS provides you SSO through NTLM, Kerberos, certificate-based, basic authentication, or whatever you can imagine. ADFS only works with federated domains. And as said earlier, it requires a full redundant setup on your side to be able to not lock anyone out. And that's really, really annoying. So to overcome the challenge with ADFS, someone came up with the brilliant idea of using Kerberos tokens. I don't know why they didn't think of this before, but someone eventually dove into an old 1990 book and thought this is actually really cool. So the SSO itself, according to the documentation, it only works with managed domains. And there's actually a trick to make it work with federated domains as well, which is actually pretty scary because it means I can do single sign-on to my Office 365 tenant without the ADFS noticing that I'm actually logging on. Right? So it simplifies SSO and simplifies logins, works with all domains. Yep, and that's it, because the rest one is the other one. So how does it work? So this is a simple overview. So you have your domain controller, and there's a sync going on, or actually a one-time setup between the cloud and your on-premises. And you have a domain joint machine that basically requested a ticket from your domain controller, sends the ticket up, and it's trusted. But let's see that in action. So on the left side, you see that there's a lot less components required. And here we still have Azure AD Connect. So when you install Azure AD Connect and you select the checkbox, I want to use seamless sign-on, what happens in the background is there's an computer object being created inside your domain, and the object is always called Azure AD SSO ACC. It gets an SPN, or two SPNs, and it's actually a host SPN. And those host SPNs are basically two URLs that are not inside your domain, but outside of your domain. What we do is we take the password of this particular computer account and we send it over to the hybrid identity service. That's why you need to log in once, so that the hybrid identity service can keep that host password. Now, when the user goes to My Apps or the login page itself, he actually hits a pre-STS, and everybody hits it. That pre-STS is this URL or it's this URL. What your client will do, or what the pre-STS will say to your client, is please give me a Kerberos login. So your client will go to your domain controller and say, is there a computer object or another object with the SPN of autologon.microsoft Azure AD or AADG Windows.net? Luckily, we have that particular account. So what will happen is the domain controller will set up a session ticket where one side of the session ticket is the session ticket for the user, right, the gray one, and the green one is encrypted with the password of this particular computer, of that particular object. So the user gets the ticket. The user can actually read the gray area of the ticket, and from that it retrieves a session key. It forwards the rest of the ticket to the pre-STS, and the pre-STS, because it has the password from here, can actually extract the session key from his side of the ticket. And what happens next is they agree on the session key. The pre-STS says, since you know the session key that I know, you must be able to decrypt this ticket, and therefore you're logged in. Right? So there's no background communication anymore. Azure AD itself doesn't talk to Active Directory or through an agent or whatever. The entire top section here, you can discard that. That's only for the setup ones.
Can you use another identity provider off-site? So user logged into AD with credentials, user credentials, workstation credentials, and then you, instead of hitting Azure AD, it uses another identity provider to federate the hundreds of other apps. To say it's using a virtualized instance of Oracle's IBM or Radiant Logic or another virtual.
No, I don't think so. I'm fairly sure. Because the other side needs to be able to read the Kerberos ticket, and in order to read the Kerberos ticket, it needs to have the password of this particular object. So if you have any, unless someone else thinks of the same idea, then no. So in order for this to work, you have those two SPNs. The URLs that you're hitting, these two, must be in the trusted internet zone on your client, or it must be the Windows authentication approved zone. The client, in order for SSO to work, must go to a tenant-specific URL. So if you just go to myapps.microsoft.com, system doesn't know who you are or where you're coming from. So you go to myapps.microsoft.com/mytenantid. Right? The client must be able to contact the domain controller, either via VPN or direct. And you can actually use klist to validate if Kerberos was used for the single sign-on. So let's go to the demo. So on the same client, and I'm actually logged in as Forest User 1, and I said that's just a regular user. I'll do klist purge so that you can see that there's no tickets at all. I'll open Internet Explorer and I can go to myapps.microsoft.com and then my tenant URL, tenant ID. One. Access panel doesn't want to load, but oh, there you go. Right. So if I now do klist, you see that I have KBGRT ticket, the standard one that we have in order to, that's my standard authentication. And here is the ticket for the Office Azure Active Directory service itself. Right? So does anyone notice anything on this one? And then specifically the top one.
Can you zoom in?
Oh, sorry. So this user is a user on forestroot.net. It has a UPN of forestroot.net. And I'll show you the difference of single sign-on versus what happens if I go to my apps. Oh, needs to in private. So I'm forest user 1 at forestroot.net. Fingers crossed it works, because yesterday it didn't work. This is a federated user. So because I specified in the tenant settings my tenant master URL, forestroot.onmicrosoft.com, that's why Kerberos worked and redirection didn't work at all. But because the redirection worked, I could get a Kerberos ticket, and the Kerberos ticket doesn't care about my UPN, because it's not federated, and it just hands over the ticket. The other guy can read the ticket and says you're authenticated, that's it. Right? So I'm bypassing my federation server completely and still have single sign-on. Obviously it works with all the other domains as well. But it's a really nice feature. It actually works on most of the browsers. According to the documentation, it works on Google Chrome as well. I have tried to make it work today, but I couldn't. I don't know why, but they say it's supported. But on the Vivaldi and the Firefox, I made it work without any problem. So I think it's pretty cool.
What about Edge?
Yeah, it has.
Does anything work with it?
That's a loaded question.
So this is a service. I don't have Edge on it. But when they released it, Edge was not supported. I have no clue why they didn't include that, but I think it's now supported or not yet. But they are going to make it supported like really fast, because they need to.
Because somebody might use it.
Because somebody might use it. Yeah, so the other demo that I wanted to show you as well, and this is actually going to be really on the edge, because I haven't tested it completely yesterday. So that computer object that gets created in your Active Directory, of course it's not a real computer. And because it's not a real computer, it doesn't reset its password every 30 days or whatever your password policy is. So if you don't change anything, that password's going to stay on there forever, which is really bad. So there's a PowerShell script that you can execute, and the PowerShell script basically says reset the password for that computer object, replicate the password or copy that password into Azure Active Directory, and everything is happy again. According to the official white paper, and I'm fairly sure that a lot of people are going to moan at this next sentence, according to the official white paper, you can only do that with a domain admin credential, which is like the worst thing ever. So I actually found out that you can basically, so this is my computer container, and this is the actual object. I don't know if anyone can see, but the zooming is really awful. So you go to properties, you go to security, and you basically say, so this is my forest user 1, and I said you are allowed to change the password and to reset the password. Right? So I tried this at home on a member server, and that works brilliantly. But I'm running it on a domain controller right now, which I know is really bad, but
It'll work.
apparently regular users cannot log into domain controllers by default. Nope. I wonder why.
Make the account a server operator. That'll fix it.
Connect, import, module Azure AD SSO. So this is the module, and what you basically need to do is new Azure AD SSO authentication. New Azure AD. And this one basically asks you for the credentials for Azure AD. So your global admin. And I have a very good one. .onmicrosoft.com. So as you can see, it would normally ask for MFA as well if you have that enabled, or if you know the password. So that's one. And the second one that it's going to ask you for a credential is get credential, and then this one is for the on-premises. So forest root slash forest user 1. Okay, we got that one. And then it's update Azure AD SSO forest minus on-prem credentials. Credential. Yeah. No, invalid. Anyway, I won't bother you. But basically what it does is it resets the password on all different levels. Maybe we can do... Okay. Anyway, it will reset it on both sides. So the downside of this again, and that's my feedback to the product group, you cannot make a scheduled task out of this. Because you need to have the Azure AD SSO context. And the Azure AD SSO context is a modern authentication, so it doesn't take any predefined credentials. So the feedback that I gave is like, put it into the Azure AD agent, and then when it does a reset, same as pass-through authentication, because that one does a reset as well. Just make sort of like a similar thing, but for now it's a manual reset that you have to do. There you go.
Does anything bad happen if you don't reset the password, other than you have a stale password floating around?
No, not really.
That just keeps working?
Yeah. Yeah, it's just that, so the kernel tickets themselves, they would go over the blank line, right? So if I'm a hacker and I apparently tapped into your internet pipeline, as long as I can get enough of those Kerberos tickets, eventually I might be able to get to the password. So that's it. Right?
You should probably be treating it as a TGT, because basically all their Azure AD authenticated users will end up, their credentials will end up being encrypted using those hashes of this computer code.
So the credentials of the users themselves are never sent, right? They're not in the Kerberos ticket.
Right, but
No, it's just another server, like a web server. Standard service ticket.
if you have the TGS of the computer account, you can re-encrypt anything.
Yeah, but this is, if you have a...
You can impersonate anyone and send those credentials to Azure.
Yeah.
So
No.
So you only have a session ticket. So the thing is that if you get enough session tickets, you would be able to eventually get to the password.
You have to get a cloud, like
TGT.
domain credentials as well.
Yeah.
Purpose that.
You need the, if you have the TGS, so if you have the credentials of the computer account, okay? Let's say you have the hashes of the computer account, that means that you can request.
So if you have the credentials of the computer account, you can catch other tickets and you can extract session keys. But you would only have session keys. It won't allow you to have any other. So if you have a session key and I make a honeypot server, I can basically say, yes, accept inbound traffic. I accept your session key, and I can actually encrypt my time, send the session key back. So now we have mutual authentication, but I'm not who you're actually trying to talk to. So as soon as you then exchange information with me, that information goes to me and not to the actual server that it needed to go to. So ultimately, I think the impact of leaked, if someone knows the password of that particular computer object but doesn't have access to your Active Directory, I think the damage would be minimal, because they also have to set up a honeypot, they have to do DNS redirection, and then they can get to your session key, but that's it. Right? So why would you use this over ADFS? So this is sort of like an architecture slide that I put in. So Active Directory used to be the focus point for all authentication and authorization. But with Azure Active Directory, or cloud in general, a lot of that authentication is now shifted towards Azure Active Directory. You basically have like a split brain syndrome where half of your applications and the audit logs are happening in Active Directory, and the other half is happening in Azure Active Directory. Right? So according to me, Azure Active Directory will be the new focus point. So anyone who logs into applications, either on premises or in cloud, should use Azure Active Directory, because then you have centralized auditing. The auditing in Azure Active Directory is, according to me, a lot more simplified and easier to read than Active Directory. Go take a look at the security log on a domain controller, and it's like this long. Go take a look at the Azure Active Directory login. It's also this long, but it's actual individual users logging on to particular applications, and it's noted which applications, which IP address they came from, and at what particular time they logged in. And it's really easy to see. Azure Active Directory also provides you with conditional access. And you can actually publish, if you say I have internal SharePoint or other web servers, you can actually publish those using Azure AD App Proxy, so that users from outside can actually log into those as well. And logging into those applications is also logged by Azure Active Directory. The biggest one for this one, certainly for PTA, is DDoS prevention and preemptive lookout. So if you have ADFS running, and as you saw in the previous session, anyone can really easily find your ADFS farm, see what kind of web server it's running, if you're missing any patches, ultimately hack into it. When you use password authentication, you use the authentication of Azure Active Directory, which is part of the Microsoft Authentication service. And that one, latest number I get, is about 400 billion authentications per day. Right? So it's actively protected. It uses artificial intelligence for those conditional access rules and everything else as well. The advantage of it as well for your on-premises, if you use the AD proxy connector, is you only allow pre-authenticated access into your network. If you have ADFS, so say this is my ADFS server, people would be able to hack your ADFS or connect into your ADFS web proxy unauthenticated. If you use Azure AD connector, everybody is authenticated that comes into your network. So that said, since Azure Active Directory is now here, a lot of bad guys can try to guess usernames and passwords. Right? They do it on ADFS as well. I actually had a few customers that had ADFS. They were under attack from India or Japan or whichever, and it ended up with locking all of their accounts. Someone apparently had their mail list, so all their email names. So they were just trying email names with like 10 different passwords per user. Every 10th attempt resulted in a lock of the Active Directory account, and that's pretty annoying. So in order to prevent you with that, and I have actually two solutions. If you use Azure Active Directory solely, you can actually enable it. In Azure Active Directory, that basically says lock a particular user account for a particular number of minutes, and increasingly expand that lockout account. If you use your on-premises Active Directory, you basically don't want that if an Azure Active Directory account gets locked out, your user can't log into their workstation either. Because that's really annoying if everyone comes in on Monday morning and everybody's locked out, and that's going to generate a lot of help desk calls. So what you can actually do is you can put that logout prevention on Azure Active Directory that locks the account over here, but not yet over here. Right? So users can still log into their workstations. They won't be able to log into Azure Active Directory, but after a few minutes they will. And all your administrators and everything will continue to work over here. A similar thing exists for ADFS. That's called ADFS lockout protection. So it locks a particular user on the ADFS server, but not into your Active Directory itself. And it sounds really great, but there are a few catches. So if you do extranet protection, because that's the official name for it on ADFS, it's a simple PowerShell command. It's really easy, but you have to have a web proxy. Without it, it doesn't work. The other thing is that if your farm is 2012 R2, that lock only works with a Windows with the PDC itself. So there's no fallback. If your PDC goes down, so does your protection. Which is really annoying. So that's why they fixed it in 2016. So in 2016, when you actually run the PowerShell command, you can put in fallback domain controllers, saying if the PDC itself is not available, I'll go to another one or another one. In the managed domain, if you thought we made it easy, then no way. So it works for password authentication, it works for password sync, but you can only set it through the Graph API. And in order to get to the Graph API, you need to have a P2 license. So the P2 license is only required for setting it up, for managing it. You don't require it for all your users. Right? So you just, if you don't have any P1 or P2 licenses, request a P2 trial, set it up, and then hopefully you don't ever have to change it again. That's basically it. So there are 2 URLs. I put them in here as well for review. Let's see how we're doing on time. I actually have a demo on the managed one as well, but I'll do it later on if we still have enough time. So then the question is, what next, right? So I wrote a blog post the other day, and it says, passwords are stupid. Because passwords are reused all the time. People have passwords for their, what's the name of the website that was crashed with people that go take other dates?
Ashley Madison.
Ashley Madison, right? They use them for Adobe, they use them for Ashley Madison, they use them for your corporate AD, etc., etc. If they don't use them all the time, they will probably write them down somewhere. Like, I honestly have to admit, I have some passwords on my phone as well, because I just cannot remember all of them. And if you can't remember like a complex one, then we'll probably try a clumsy one like password 1 or password 2. So that's where Windows Hello and Workplace Join come to the rescue. So what does Windows Hello do? Windows Hello works together with your device itself, so this unique computer, and my fingerprint or my facial recognition or my PIN code is stored in this computer itself. And that basically secures my private key. And with my PIN code or with my fingerprint, I'm the only one that can unlock that private key and therefore authenticate towards Azure Active Directory. Now the advantage of that is that as a user, I don't have to remember my fingerprint. The PIN code that I have is usually 4 or 6 or 8 characters long. And a lot of people say, but if you have a PIN code that's 4 digits long, it's less safe than a password. But it's not, because it's a 4-digit PIN code that's tied to this particular computer and this particular computer only. Right? And the beauty of it that you don't have to have a password anymore. So users can just use their fingerprint, sign into their computer. The computer is authenticated into Azure Active Directory, and I get access to everything. I don't need seamless sign-on. I don't need pass-through authentication. It's my device that's trusted on my account and therefore signs me in automatically into Azure Active Directory. The other one that's really cool as well is if you want to get rid of passwords, and Microsoft is actively doing that, your Live ID that you use today can already use without, you can already use it without a password at all. Right? So how it works is I go to the Live ID login. The Live ID login, I type my, my username, and it will say, do you want to use your mobile authenticator on your phone to actually authenticate yourself? So I get a pop-up on my phone, I type my PIN code, and I say accept, and I'm signed in. As a user, I don't have to remember anything except the PIN code for my phone, and that's it. Right? Now, oh, that's conclusions. So it's not there yet in Azure Active Directory. I'm hoping it will be there really, really soon, because it will solve a lot of problems.
First half of next year, that was 79.
Okay. No, I didn't know it was public information, so.
Yeah, yeah. Because 79, it should be Q1 2018.
Yeah. So, but if it comes, I can almost guarantee it will work with managed domains, not with federated domains. Right? Because on federated domains, you authenticate, sorry, you authenticate to your local federation service, not Azure Active Directory. That's it. So the conclusions. Managed domains usually provide a better protection. In some cases that's not true, but it depends on the size of your organization as well as the amount of money you can throw at security. But I'm fairly sure Microsoft throws a lot more money into security and DDoS protection than any organization does to their local federation farm. And within managed domains, it's either synchronized passwords or use pass-through authentication. If you need to, so you don't want to synchronize the passwords, pass-through authentication would be my recommended model. It's not just because we think it's a very cool solution, but it's because of those new features that are coming on. They will probably only be available to manage domains. And then on the SSO, it provides a seamless experience for users. It's a little bit error prone because you need to have a fully functioning Kerberos system. ADFS could fall back from Kerberos into NTLM if there was a time zone difference or a timing difference outside of 5 minutes. This one doesn't. This is like pure Kerberos. But you can get an improved experience for users because you don't have to go to different services. And I think it's actually pretty good. And the last conclusion is apparently Kerberos is not dead yet because someone found a new use for it. And with that, I have 5 minutes to go. So if you want to contact me, it's my email address. And if you want to know more about how this works or see the slides, but then with text in there as well, go to my blog. And that's it. Any questions?
What would be the reasons for you keeping ADFS then?
Mainly, so the biggest one would be custom MFA providers. So the number one feature request that a lot of companies had was, why are we forced to use Azure MFA while I'm already using RSA or any other token? So that's why on the last Ignite they announced that they're going to support multiple vendors as pure cloud MFAs. So then you don't have to use your on-premises MFA anymore.
Have you heard anything about whether Azure will support token encryption at all? Because it doesn't support that at the moment. That's another one of the things where RPs.
Don't know. No. That's it.